Hi, today we are looking at the last section of chapter 10, which deals with a parabola. So in the past, in grade 11, you dealt with the parabola, but we only dealt with ones that opened vertically. Today, we will look at both vertical and horizontal and how to tell from an equation whether it's going to be opening vertically or horizontally. Now, in I believe it was chapter 4, we affected quadratic functions over line y equals x, which caused them to open sideways. We did at the time talk about how they did not pass a vertical line test, and as such were not functions. However, they are still parabolas. For a parabola that opens sideways, we have equation x minus h equals ay minus k squared. So you'll notice this takes the same form as our vertex form for opening upwards, except for instead of having x minus h in here, it becomes y minus k, and our x is outside of our brackets, so is our h. Now our vertex is going to be at h comma k. The axis of symmetry is given by y is equal to k because we're going to have a horizontal axis of symmetry now instead of a vertical one. If a is greater than 0, it's going to open up to the right. If a is less than 0, it opens to the left. So example, parabola has the equation x plus 3 equals y minus 2 squared. You want to identify the direction of opening, coordinates of the vertex, and the equation of the axis of symmetry. So direction of opening, we can see technically this is positive, so it's going to open to the right. Coordinates of a vertex, we just reverse each of these, so therefore our vertex is at -3, +2. Our axis is at y is equal to -3, or sorry, y equals 2, because it's opening horizontally, so we have a horizontal axis, so we go by our y value at our vertex. Next, we're going to graph a parabola and identify the domain and range. Okay, now we're on to graphing the parabola and identifying the domain and range. So we know our vertex is at -3, 2. So we know our vertex is here. Now, if we want, we could do a small table of values to get a few points. Now, in this case, because x doesn't have an exponent to it, we'll actually solve for x value. So essentially, on this side, we'd have x equals, rearranging this equation, we get y minus 2 squared minus 3, and here we've got our y's. Now, we know our vertex is at -3, 2, so I'd have -3, 2 here, then probably do 1, 0, 3, and 4. So if I put 0 in, I've got 0 minus 2 squared minus 3. So 0 minus 2 is -2. -2 squared is 4. Minus 3 is 1. Next, we have 1. So we've got 1 minus 2 squared minus 3. So 1 minus 2 is -1. -1 squared is 1. Minus 3 would be -2. Next, we have 3 minus 2 squared minus 3. So 3 minus 2 is 1. 1 squared is 1. Minus 3 is -2. Next, we have 4. So we've got 4 minus 2 squared minus 3. 4 minus 2 is 2. 2 squared is 4. Minus 3 is 1. So plotting these at 1 for x, we're at 0 for y. -2 for x, we're at 1 for y. -2 for x, we're at 3 for y. 1 for x, we're at 4 for y. So this is our parabola. So from this, we can say we have a domain. The lowest x value we have is -3, so x has to be equal or greater than -3. Our range, this is going to continue forever upwards and forever downwards, so y would be all real numbers. Okay, so our general form of equation of a parabola is ax squared plus by squared plus cx plus dy plus e equals 0. However, we need a to equal 0 or b to equal 0 because we can only have one squared term. Otherwise, we will end up with a circle, ellipse, or a hyperbola. So for example, parabola's equation is 2x squared plus 24x plus y plus 68 equals 0. Determine the coordinates of the vertex and the direction of the opening. So we can see that in this case, our only term with a squared is our x squared. So this one will open upwards, and we would probably start by rearranging to get y on its own. So we have y is equal to -2x squared minus 24x minus 68 equals 0. We will then do completing the square of this, so that first needs us to factor out the -2. So we've got -2 times x squared plus 12x plus a blank plus 34 minus a blank equals 0. Then we're going to do our b over 2 and squared. So our b value in this case is 12. 12 divided by 2 is 6. 6 squared is 36. So we've got plus 36 and minus 36. Now these first three terms form our perfect square trinomial. So we've got y equals -2 times x plus 6 squared. And then combining these, we get -2. We'll expand this out. So we've got y is equal to -2 times x plus 6 squared. The -2 times -2 is +4. So we can see that because this is y equals, it's opening vertically. Because it's negative, it's opening down with a vertex at -6, 4.